Hey everyone, in this video we'll cover all the inequality property starting from basic to advanced. Let's begin. First, trichotomy property. For any real number a and b, only one can be true. Either a is greater than b, or a is equal to b, or a is less than b. Apart from this, nothing can be true. Next, if A is greater than equal to B, it implies either A is greater than B or A is equal to B. For example, 16 is greater than equal to 15. Either 16 is greater than 15 or 16 is equal to 15. One of them has to be true. Third is symmetric property. If A is greater than B, it implies B is less than A. So simply reverse the statement. Now that you know the basics, we'll move forward to the moderate properties. Fourth is addition property. If A is greater than B and we add same number on both sides, then the inequality does not change. If we add both sides by any number C, A plus C remains greater than B plus C. You'll understand this better with an example. We know that 5 is greater than 3. If we add 2 both the sides, on one side 5 plus 2, other 3 plus 2, and clearly 7 is greater than 5. If we extend this addition property, let's say A is greater than B and C is greater than D, then A plus C is greater than B plus D. For example, 5 is greater than 4 and minus 1 is greater than minus 2. If we add both the larger numbers, 5 plus minus 1 is 4 and 4 plus minus 2 is 2. Clearly 4 is greater than 2. Just like addition, we'll talk about subtraction property. If A is greater than B, then subtracting same number on both sides does not change the inequality. So A minus C remains greater than B minus C. So 5 is greater than 3 and we subtract both sides by 2. So 5 minus 2, 3 will remain greater than 3 minus 2, 1. Extending this property, if A is greater than B and C is greater than D, then A minus D is greater than B minus C. On one side, you have larger number minus smaller number. On other side, a smaller number minus larger number. This property comes very handy in exams. To understand this better, let's take an example. So 5 is greater than 4 and minus 1 is greater than minus 2. If we subtract 5 and minus 2, this becomes 7 and 4 and minus 1 becomes 5. Clearly 7 is greater than 5. Next is multiplication property. You have A greater than B. When we multiply both sides by a positive number, let's say C, AC remains greater than BC. The inequality does not change. For example, minus 3 is greater than minus 4. Let's take C as 2. Minus 3 into 2 is minus 6. Minus 4 into 2, minus 8. And minus 6 remains greater than minus 8. But what will happen if we multiply both sides by a negative number? That means your C is less than 0. Note it down. In that case, the sign reverses. That means AC will be less than BC. Why is that? We know minus 3 is greater than minus 4. If we multiply it by a negative number, take C as minus 2. So minus 3 into minus 2 becomes 6 and minus 4 into minus 2 becomes 8. Clearly 8 is greater than 6. So the sign reverses. Next is division property, which is similar to multiplication property. If we divide both sides by a positive number, the inequality does not change. So if A is greater than B, A by C remains greater than B by C. Like 8 is greater than 6, taking C as 2, 8 by 2, 4, is greater than 6 by 2, 3. And if we divide both sides by a negative number, similar to multiplication property, the sign here also reverses. So if c is less than 0, a by c will become less than b by c. We know that 8 is greater than 6. Taking c as minus 2, 8 upon minus 2 becomes minus 4. 6 upon minus 2, minus 3. Clearly, minus 3 is greater than minus 4, and here also the sign reverses. And now we are left with three most important properties where many mistakes can happen. So listen carefully. First, exponent property. In exponents, we only talk about positive numbers, so a and b should be greater than 0. In first case, if a is greater than b and r is greater than 0, then a raised to the power r is greater than b raised to the power r. Don't worry, we'll understand this with an example. 9 is greater than 4. Take r as 1 by 2. So 9 raised to the power 1 by 2 means 3 and 4 raised to the power 1 by 2 means 2. And we know 3 is greater than 2. But what if r is less than 0? In that case, as you can guess, the inequality reverses. Like from the previous example, 9 is greater than 4. Take r minus 1 by 2. So 9 raised to the power minus 1 by 2 becomes 1 by 9 raised to the power 1 by 2 or 1 by 3. And 4 raised to the power minus 1 by 2 is 1 upon 4 raised to the power 1 by 2, that is 1 by 2. And we know that 1 by 2 is greater than 1 by 3. So here the inequality reverses. Next is the law of reciprocal. If a is greater than b, what can you say about 1 by a and 1 by b? If a and b have same sign, that means either both are positive or both are negative. Then while taking reciprocal, the sign of inequality gets reversed. Like 4 is greater than 3. So what about 1 by 4 and 1 by 3? Clearly 1 by 3 is greater than 1 by 4. Also minus 1 is greater than minus 2. If we take the reciprocal, minus 1 by 2 become greater than minus 1. In both the cases, the inequality is getting reversed. Now let's see what happens if a and b have different signs. If a is greater than b, let's take 5 greater than minus 1. If we take the reciprocal, 1 by 5 remains greater than minus 1. In this case, inequality sign does not change. We'll end this video with the last and the most important property, that is squaring of inequality. Remember, if a is greater than b, then you can say nothing about a square and b square. It may or may not be greater. Understand this deeply. Like 3 is greater than 2. If we square both the sides, 9 is greater than 4. But also 3 is greater than minus 4. Now if we square, is 9 greater than 16? No. So for this property, there is no particular rule. It is on case-to-case basis. This is all about inequality that you need to know to gear up for exams.